All right, so greetings, and welcome to Eureka Math Squared. This is grade 6, module 4, lesson 17, all about equations. Equations and solutions. Getting to the good stuff, okay? Basically, what we're looking for here is a value, a value that makes an equation true. Value, or perhaps more than one, that makes an equation true. Okay, but first, I guess they want you to practice some writing some expressions or equations, right? So if I have 8 more than 22, that means I start with 22. And if I want 8 more, I'm going to add 8 to that. Okay, or perhaps over here, 33 divided by, so I love using a fraction bar there. So 33 on top, right, divided by the sum, that means to add 8 plus 3, like that. Okay, so, and we can keep on going and do a couple more. Well, we can actually combine this too, I suppose. We could just say, hey, 33 over 11, right? And then keep on going, but maybe they just wanted this. I'm not sure. Okay, but how about this one? 10 is 1 more than 3 squared. 10 is, oh, is means equal to. Now we're getting to equations. Cool. Equation has the equal sign. The expressions do not. Right? So expression, equation equals 3 squared, but 1 more than that. So 3 squared, 1 more than. So I'm going to add 1, just like that. There it is. So 10 is, right, 1 more than 3 squared. There you go, 3 raised to the second power. How about this guy over here, this last one? So 3/4 of 36. Of means to multiply. So 3/4 of 36, let's see how this goes, is the product of, let's see, is the product of, there's that is, so equal to the product of 3 and 9, like that. There you go. That looks like fun. Let's see if this is actually true. Let's see, so if I multiply these guys, I get a little 27. If I take 3/4 of 36, let's see, 4 goes into 4 once, 4 goes into 36 9 times, right? 9 times 4 equals 36. And so I'm left with 3 times 9, which, guess what? 27. But again, I think they just wanted the equation, right? Notice the equal sign. Sorry about that. So here we go. What's next? Oh, what makes it true? Okay, so now we're finding for solutions to equations. I want a value. I'm going to put a variable there. Okay, so I need to find the value of that variable. So first thing I'm going to do is, well, see what I can do mathematically to simplify this. There's nothing I can do with that 14 minus n. I'm going to leave that. But on the other side, I sure can. That guy right there. 2 to the third power equals 2 times 2 times 2. Right, there's a 4 times 2 gives me 8. So there's an 8 plus a 5. We're not done yet, so let's see. Let me get rid of this. I just need the space. So I'll bring this over here, over there like that, right? 8 plus 5, and now we can just add those, right? So that gives me 13 equals, and notice I'm keeping everything in the same order. So the question is, well, what must be the value of n? If I take 1 away from 14, I get 13. That has to be a 1, right? Has to be a 1. Da-da-da, just like that. There you go. Okay, so that's kind of what we're doing here. Let me use the distributive property here. So 1/2 times the 30, right? Distribute that 1/2. Minus, right? There's a minus. We take that 1/2 here and distribute it using multiplication to that 12, right? There's that 12 equals, boom, equals 5 plus something, but I'm going to use a variable. I'm going to put a variable there. Okay, so now we keep going. Half of 30, well, that's 15, right? Minus half of 12, well, that's 6, equals 5 plus some number. Now I can deal with this, right? So that's 9 equals 5 plus n, and the answer now should be shouting at you, right? So 9 equals 5 plus 4. So that bugger has to be a 4, okay? And that's really what's going on here today. A lot of fun little practice like this guy here. right? So 7 times something equals 51. What is that something, right? So we can solve this algebraically, but I don't think they want me to do that just yet. So let's see, 7 times 10. No, that's not going to work. How about a 7 times 15? That seems pretty large. How about a 7 times 3, right? That gives me, uh, oh, 17. What am I doing there? 17. That works. I'm saying to myself, there's nothing that'll actually work. 17 times 3, that'll give me that 51. Sure. Okay, so that works. So there goes the 3, right? This guy here, 4 squared, well, 4 squared equals 4 times 4. That gives me 16, right? So he's done. Right, so there you go, there you go. I think they want to match. They want matching. We're just going to draw that to that guy. We'll draw that to that guy. And let's see, 1/2 times, oh, excuse me, 1/5 times something, right? It's going to give me 2. Well, let me pull something in here. Let's see, 1/5 of that, right? So if I put something over 1 there, let's see if I put a 10, that'll work, right? So if I get a 10 up there, that'll work. So 10, right? Because 10 divided by 5, right? Because 1 times 10 gives me the 10. The 5 times 1 gives me 5. That equals 2. And there's only one left. It has to be this guy. Let's just make sure. So if I put a 15 in place of that n over 3, well, 15 divided by 3 equals 5. There it is. There's that 5. And that's the deal. All right. So lots of fun here. And we can keep on going if we want. What value actually works? Which one? So let's see. Oh, we'll just do this last one right here. Let's see what's going on here. I think I have to do one at a time here. So if I do my A, and let me write the expression. In this case, not an expression, right? It's an equation, because that's the equal sign. And I plug in the 10. So 2/5, right, times 10. Every time you see an x, you put a 10. Equals 10 minus 3, like that. So put that over there. That goes once, that goes twice. That's a 4 plus a 9 equals 7, right? Because 10 minus 3 is 7. This gives me 13. Oops, not plus. Gives me 13 equals 7. That's not true. So he's out. No way. He's not working. Takes care of that guy. Let's do B. So 2/5 times plus the 9 equals x minus 3. And we'll plug in the 15, right? So we'll use multiplication there. Put that over 1 plus 9 equals, there's that 15 again, right? Every time you see the x, there you go. So now I have a 12 over here. Let's see. 5 goes into 5 once. 5 goes into 15 3 times. So I have a 6 plus 9. Right, that gives me 15. 15 equal, oh, excuse me, 12? No. So that's not working. That goes 12. That's no dice. Nope. 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 Big no. Okay, so let's see. Am I running out of space here? I am. I'll have to work a little smaller. Let's do part C. C, 2/5 x plus the 9 equals x minus 3. So let's use multiplication. 2/5 times, right, the 20. There's that 20. Let me separate that a little bit. Times the 20 plus the 9 equals that same 20 minus 3. Well, that gives me 17, right? If I simplify here, 5 goes into 5 once. 5 goes into 24 times, so I get an 8 plus 9. There you go. If I combine that, I get a 17 equals 17. There you go. Aha. So that works. Should I keep going just to make sure? Why not? 2/5 x plus the 9 equals x minus 3. And this is part D, by the way. Part D. X is, x is 25, right? So 2/5 times 25 plus the 9, right? There's the 9, equals 25 minus 3, right? There was that x equals 25. So this guy minus this guy, right, gives me 22. And if I simplify these guys, 5 goes into 5 once, 5 goes into 25 5 times, 2 times 5 gives me 10, plus that 9, right, there's that plus 9. That gives me 19 equals 22. No. Big old no. So he's out. Okay. That's the deal, folks. All right, so we're just messing around with equations and trying to find solutions to them, meaning we're looking for the missing value that makes everything true. All right, so that's a deal. I hope you enjoyed that. Take care. So long. Bye bye.